let's just move on further towards the new topic, which is nothing but called as the operations on the real numbers. Now, what we will do in this particular topic, we will apply the various mathematical operations like addition, subtraction, multiplication and division on the real numbers. But before that, let me recall some of the properties on the rational numbers which are now applied to the properties or now called as the properties of the real number. So let us suppose I am recalling all those properties that we already have done in the class 8th. So the very first property is nothing but called as the commutative property. What is the meaning of commutative property? So let us suppose we are talking about any particular two numbers a and b. So a plus b is always is equal to b plus a. This is nothing but called as the commutative property. So let us suppose I am talking about any real number a and b. So a plus b can always be is equal to b plus a. You can take any particular example for this. Let us suppose we'll take a as 2 and b as 3. So 2 plus 3 is always is equal to 3 plus 2. Further, let us suppose we are talking about multiplication. So a into b is always is equal to b into a. This is all about the commutative property. It says that for any two particular numbers a and b, these results follow under addition, under multiplication. So these are two results, under addition, under multiplication. So let's just move on towards the second property, which is nothing but called as the associative property. What is the meaning of associative property? Associative property says that for any three numbers a, b, c, under addition operation, a plus b plus c is always is equal to a plus b plus c. So either you'll add these two numbers first together, or let us suppose you'll add these two numbers first, and after adding these two numbers you'll add c in it. Answer is always the same one. So further, if we'll talk about under multiplication, so a into b into c is always is equal to a into b into c. This is called as the associative property. So the very last, or we can say the only property, is nothing but called as the distributive property. So what is the meaning of distributive property? It is actually a combination of addition and multiplication. So let's suppose we are talking about any three real numbers or any three numbers. So a into b plus c is always is equal to a into b plus a into c. So always remember all these three properties in order to solve the real numbers, or in order to operate with the basic or the various operations on the real number. So these are the three properties. We have to remember these three properties all together in order to do the question. So let's just move on further towards the further concept in which we will talk about the operations again. So let us suppose we are talking about the operation addition, subtraction, multiplication and division, and we will now discuss about the rational, irrational and a combination of the numbers, that whether after adding a rational and a rational, or a rational and irrational, or irrational and irrational, what will be the answer that we will get. So now we are actually checking out what kind of a number we will get at the end after adding any two rationals, any irrational and irrational, and any irrational plus irrational. So let us suppose we are talking about under addition. First of all, if we are talking about a rational and irrational under addition, so let us suppose take any particular rational number. So let us suppose I am taking 2 and 3 and I am adding 2 and 3. So let us suppose I am adding 2 plus 3. As we know that the answer of 2 plus 3 is nothing but 5. So 5 is definitely a rational number. So it is a rational number. So let us suppose I am writing it over here as R, where R is representing rational and IR will represent irrational. Let us suppose. So now the addition of two rational number is nothing but a rational. So I get the answer as, after adding two rational all together, we get the answer as rational. Let us suppose we are talking about the subtraction, and I will take any two numbers. Let us suppose half and 1 by 3. So let us suppose I am talking about half minus 1 by 3. So the answer will be like, it is a rational, it is a rational, we are subtracting two rational number. So it will be like 3 minus of 2. After solving it, it will be like 3 into 2 is 6, which is nothing but 1 by 6. So it is 1 by 6, and 1 by 6 is again a rational. So it means that the subtraction of two rational number is again rational. So let us suppose we are talking about the multiplication, and if we'll take any particular example, let us suppose I am taking 5 and 6. So 5 is a rational, 6 is a rational. So 5 into 6 is nothing but 5 into 6 is nothing but 30. 30 and 30 is nothing but a rational again. So it means that the addition of two numbers is rational, the subtraction is rational, the multiplication is rational. Let us suppose we are talking about division of the two rational. So if I'm taking 2 and 3 again, you can take any particular number. So let us suppose I'll take 4 and 5, different from 2 and 3. So let us suppose I'm talking about 4 and 5, and 4 is a rational, 5 is a rational. So the division that we are getting is also a rational. So at the end, what is the conclusion? That the addition, subtraction, multiplication, division of any two rational is always a rational number. So let's just move on towards the second block, in which we will talk about addition, subtraction, multiplication and division of a rational and an irrational. So let us suppose I'm talking about addition. So let if we are taking the rational number as 2 and an irrational number as root 2. We know that 2 plus root 2 is nothing but an addition of a rational and an irrational. So we cannot add these two numbers because these two numbers are definitely not like terms. We can only able to add the like terms only, and they are not like terms because one is a rational, other one is an irrational. So the answer of this is again this. So it is definitely an irrational number. So it is nothing but irrational number. So I'm writing it over, writing it as IR. So it is nothing but irrational. It means that the addition of a rational and an irrational is actually irrational number. So let us suppose we are talking about subtracting the two numbers, that is a rational and an irrational. So let if I am subtracting a rational and an irrational. So let us suppose we are subtracting 1 and we are subtracting root 3. So 1 minus of root 3. Obviously we cannot subtract these two numbers again because they are not like terms. So hence the answer is again nothing but irrational. So this representation is also irrational. Let us suppose we are multiplying a rational and an irrational. So let us suppose I am talking about multiplying 1 by 2 with the square root of 21. Let us suppose. So 1 into square root 21 is nothing but square root of 21 and divided by 2. So square root 21 divided by 2. Obviously we cannot divide these two numbers. So these numbers are nothing but representing the irrational numbers again. So let us suppose I am writing it over here as IR. So this number is again irrational. This number is again irrational. Let us suppose we are talking about dividing a rational and an irrational. So let if I am dividing a rational and irrational in the formation of let if I am taking 1 as a rational and a square root 3 as an irrational. So 1 by square root of 3 is definitely an irrational number again, because if we will factorize or we will rationalize the denominator of this particular number, as we know that 1 by square root 3 we can rationalize it as multiply the same number or the same irrational number in the numerator as well as in the denominator. This is all about rationalization of a particular number. The rationalization can only be taken if we will multiply any particular irrational number with the same irrational number in the numerator as well as in the denominator. Such a process is called as the rationalization. So this is nothing but 1 into square root 3, which is 3. Root 3 into root 3 is nothing but 3. But again, this number is definitely an irrational number. So it says that the addition, subtraction, multiplication and division of any rational and irrational always results in an irrational number. So it always results in an irrational number. So let's just move on further toward the third kind, in which we are talking about irrational and irrational. So let us suppose I'm talking about the addition of irrational and irrational. So let if I'm taking square root 2 and square root 3. If I'll add square root 2 plus square root 3, so it will be like root 2 plus root 3. We cannot add root 2 and root 3 together because they are not like terms. So definitely it results as this only. So this is nothing but an irrational number. But let us suppose we'll move toward addition. Addition is root 2 plus root 3. Let us suppose we are moving toward the subtraction. So we have to take any two irrational numbers. So let us suppose I'm taking root 5 and I am subtracting root 5 with root 5 again. I am subtracting root 5 with root 5 again. So we know that the subtraction of root 5 and root 5 again is nothing but 0. So it can be a rational. And let us suppose I'm talking about subtracting root 3 and root 5 altogether. So root 3 minus root 5 will remain same because we cannot subtract these two numbers as they are not like. So it will result in it will result in this only. So this is nothing but an irrational number. So it means that the answer can either be a rational or either can be an irrational number. So let us suppose we are talking about the multiplication. The same way we can talk about the multiplication. Let us suppose I will take root 7 into root 7. If we'll multiply root 7 into root 7, the answer is 7. So it is nothing but a rational. But if we'll multiply root 7, if we'll multiply root 7 with root 3, the answer will be root of 21. 7 into 3 is nothing but 21, and this is nothing but an irrational number. So it means that the multiplication of the two irrational number can either be a rational or can either be an irrational number. So let us suppose we are talking about the division. If we'll take any particular irrational number, let us suppose I'm talking about root 2 and root 2. So if I'll divide root 2 and root 2, we get the answer as 1. Or if I'll divide, let us suppose root 5 and root 2, so it will result into the answer as common of square root 5 by 2. So this is nothing but a rational number, or this is nothing but an irrational number. So it means at the end, what is the conclusion of all these results? That first of all, if we are talking about adding, subtracting, multiplying and dividing any two rational number, they always result into being a rational number. Means the answer of any addition, multiplication, division of any two rational number will always result in a rational number, and the addition, subtraction, multiplication, division of any rational and an irrational number always results in being an irrational number. So the answer for this one is an irrational number. But the third column will be like the answer of the addition, subtraction, multiplication and division of any irrational and irrational. It can either result in a rational or an irrational, So we cannot say about adding, subtracting, multiplying and dividing two rational and irrational number that what will be their nature after adding, subtracting, multiplying or dividing them. So it can either be a rational or irrational number. So always remember this thing, that whenever we will add any two rational number together, subtract two rational number together, or either multiply or divide, it will always result in being a rational number. If we'll multiply and divide the two numbers which are rational and irrational, it will always result in being an irrational number. Their nature is always irrational. And if we'll subtract, divide, multiply any two irrational and irrational together, so it may either result into a rational or irrational number. I hope the whole concept is all clear to you.